well, we've learned a lot from each other. One thing that hasn't changed, I've discovered, is my wardrobe. This is the shirt that I wore 8 years ago at the meeting at the Perimeter Institute. There's been a lot of thanking going on, and I appreciated the thanks that people gave to Matt and I for our role in the collaboration. These are the principal investigators of the It from Qubit collaboration. I just wanted to thank them because one of the things that's made it such a success is that everybody on that screen stepped up and invested a lot of time and effort into making things run. I won't go through everybody, but as an example, Rob organized the very first meeting, large meeting here at the Perimeter Institute, which remains one of the most exciting scientific conferences I've ever attended. Tadashi Takiyanagi organized a school in Kyoto, Horacio one in Bariloche. Well, we could go down, we'll go down the list. When it was just about time to submit our final application for the collaboration, my first child was born, and so Alex Maloney stepped up and did the final edits on the application. So everybody really did a huge amount of work, and that collective effort is responsible, I think, for a lot of the success. Oh, I do want to mention that Juan every year organized a workshop at the Institute for Advanced Studies. That was a tremendous effort as well. I was going to thank the organizers of this meeting, but Alex got there first, but one person we did not thank was Alex himself, and so a round of applause to Alex. And over the course of these 8 years, one of the things that we tried to achieve with the collaboration was to form a community, to train a new generation of scientists conversant in both quantum information and the more traditional tools of high-energy physics. And this conference, I think, is evidence of, well, how that has gone well. And so it's just very exciting to see so many ideas bubbling up, so much excitement still in this field at 8 years on. And I had originally...
Brian, what's going on?
I included that one of Brian, even though that wasn't taken here. That was last winter, I think, at the Simons Foundation. I was going to use this time to reflect a little bit on what had been accomplished and what we could do going forward. But John Preskill, during his after-dinner talk, actually, I think, did a very nice job of that. It is a solemn, maybe a bit of a solemn occasion. And so I thought that the appropriate thing to do was to host a game show. And so I'm going to put on a different hat, and I'll say, welcome to Say It Ain't So, the only game show themed with quantum information and quantum gravity where the audience gets to play along. I am your host, Patrick Hayden, and let's get started. Those of you in the audience here in the studio or watching online, I encourage you to pull out your phones, your computers. You are going to get to participate by responding to various polls. We have 4 contestants today, so I'll call them down. Our first contestant is John Preskill from Pasadena, California. John, can you come down? I'm told that John's hobbies are playing with his grandkids and advising the NSA. That sounds very exciting, John, and a lot of fun. I mean, the grandkids, I mean. How many do you have now?
I can't tell you about that.
All right, our next contestant is Daniel Harlow, coming to us all the way from the Aleutian Islands in Alaska. That is correct, is it not?
My twin brother is in Alaska. Yeah.
Ah, so you and your twin, you must be very similar.
He has a big beard and tattoos.
Maybe not so similar, all right. But you both live lives of splendid isolation? Yes.
Indeed.
Okay, our next contestant is Ted Jacobson, coming to us from College Park, Maryland. Come on down, Ted. So Ted, I'm told that you almost you ran a freelance bakery in an earlier life. And so why did that career not pan out for you?
It wasn't the most interesting thing I could think of.
Fair enough. Well, it's great to have someone with your expertise on the panel. It's quite a rare treat for this show, I'll say. And so last week I tried to bake some banana bread. It was both very wet and burnt at the same time. So can you give me any advice on that?
That's the ideal for banana bread.
All right. Good news. And our final contestant is Brian Swingle from Boston. Come on down, Brian. So Brian, I heard a little story about you recently, very sweet, that you had named a tensor network after your wife, Nora, is that right?
Yeah, his different wife.
Oh, so Nora is not your wife's name?
No.
Oh, what is her name then?
Louise.
You're happily married?
Yes.
And so is Louise here cheering you on in our studio audience today?
Unfortunately not, no.
No, she must have had important things to do, but I'm sure she's watching online, offering her moral support.
No, I don't think so.
All right, well, Brian, I don't know what you did to get her angry, but I suggest that you pick up a big bouquet of flowers and apologize profusely when you get home.
Will
and
do.
perhaps change the name of your tensor network. All right, we are ready to go. The way that this is going to work, I'm going to show you a question, and the audience will get to answer the question in the poll, and our contestants will also answer the question by selecting a card. They have letters on their cards. It's multiple choice. And so they should choose a card and put it face down on the table so you don't know exactly what they've chosen, so they don't bias your choices. Now, science is an enterprise where we try to reach consensus, and so acknowledging the importance of consensus, if our contestants match the most popular audience response, they will get 5 points. On the other hand, consensus is not always correct, and so you'll see, we'll get there in a moment, that there will be ways to get points even if you violate the consensus. But I won't describe that process quite yet. Let's just get started. First question, and can we activate the poll? The interior of an old black hole and its radiation are A, different aspects of the same thing, or B, independent of each other. I'll give you, I want this to move along, so I won't give you too long to answer. I see faces up. All right, let's see what the audience responded, or how they responded. Oops. I have to find it, just a moment. Ah, there it is. Oh. Technical difficulty. Just a moment. Let's try reloading that. Okay, different aspects of the same thing. Let's see how our contestants did. And you can just show them all together. Everyone agrees! 5 points for each of our contestants. I don't think that consensus is going to hold through the entire game. All right. Next up, we actually get to skip this part. The black hole information paradox is A, resolved, or B, still vexing. Open the poll, please. All right. Let's see how the audience responded. Okay, well. There seems to be a...
Patrick, they can see the answers.
Still vexing.
Well, they can now, but they've already chosen, right?
Right.
Okay, so I have to... oh, right, I have to do this. Still vexing. All right, so who chose still vexing? All right, so we still have agreement. Excellent. We're going to skip this. Okay, ER equals EPR. A, a theorem. B, a metaphor. C, an ingredient. Or D, a slogan. Okay, our contestants have chosen.
The choice is different.
Oh, I forgot to change it. Let's pretend they're the same. Now, how do I move to the next question? I guess I have to do this. All right, let's see what our contestants had to say. All right. John Preskill, you get points for the slogan. Our three other contestants are going to enter the next phase of the game. And so,
Oh, I didn't know I was voting for an aspiration.
you're committed. I'm sorry. So in the next phase of the game, what's going to happen, I'm going to read off the name of a famous scientific paper. The first person to buzz in gets 5 points. But John's not allowed to play because he already got his points for consensus.
What do they have to guess?
Now, whoever buzzes in first with that right answer then gets to articulate why their non-consensus view is a compelling one. And then we'll have a little bit of discussion involving perhaps the other contestants and some of the audience. And then our panel of evolving wisdom will decide whether to award a further 10 points to the lucky contestant.
Patrick, you didn't say what they have to buzz in to say.
Yeah,
Right.
Sorry?
You didn't say what they have to buzz in to say.
Oh, thank you. They have to buzz in with the name of the author. The name of the person who wrote the paper. Maximal extension of... Oh, wait. Actually, I didn't tell who was first.
Ted.
It was Ted.
You said wrote the paper.
I did.
You didn't say figure out the answer.
I did not.
John Archibald Wheeler.
5 points. Because Ted knows his stuff. It was a trick question. The result is due to Kruskal. John Wheeler wrote the paper without Kruskal's knowledge, submitted to physical review. The first Kruskal learned about it was when he got the proofs back. All right, what will our lucky winner get today? A trip to California, home of Yosemite National Park, Disneyland, the famous Pacific Highway, and Hollywood. Our contestant will see none of those things. Instead, our contestant will give a seminar at the Stanford Institute for Theoretical Physics, fly economy class. If they want to bring family, they have to pay their family's way, of course, and we will provide a per diem to help defray the cost of local expenses. All right, next question.
I can play.
We can hear his opinion.
Oh yeah, you just explained why.
Oh, what am I doing? I was getting carried away. Okay, let's let Ted articulate his opinion.
This was why it's a metaphor and not a slogan.
Why it's a metaphor, not a slogan. Why a metaphor is the best description of ER equals EPR.
A metaphor is not an analogy. It's more of, it has more poetry to it and a more open-ended relationship. And I think that's the nature of the relationship between ER and EPR.
Very good. Do any of our other contestants want to weigh in on that point?
Sounds good to me.
Or our audience? Anyone want to respond?
Well, it wasn't ER's like
All right, let's let our panel of evolving wisdom vote on whether to award points to Ted. 10 points to Ted for a beautiful answer. All right, next question. Quantum field theory is straightforward to simulate on a quantum computer. A, obviously, B, morally, or C, not at all obvious. All right, let's see how our audience is responding to this one. Oh. Okay. Contestants, show your cards. All right. None of the contestants went with the consensus view. And so they all get to weigh in on the next problem, the next question. I will read the title of the scientific paper. Oops. Invariant variation problems. Daniel.
Emmy Noether.
Correct. Now, Daniel. I forget how you responded, but would you like to articulate why?
Because you put it on a lattice and trotterize the Hamiltonian.
All right. You're not going to encounter any problems along the way when you do that?
Not problems that are worthy of my thought.
Any contestants want to add anything to what Daniel said?
Okay, should we bet on whether or not it's doable?
All right.
Use domain wall fermions.
John, do you want to add anything?
I think it's because I've written papers about it, and I'm not smart enough to do anything that's not obvious.
All right. Panel of evolving wisdom. Do we award Daniel the points? Oh! A stinging rebuke to Daniel Harlow. I'm sorry, Daniel. Next question. Tensor networks are A, useful models, toy models of holography, B, an accurate description of our universe at certain scales, or C, so 2018. All right, contestants, show your cards. All right, A, Ted and John have matched the consensus view. Daniel and Brian go head to head in the...
Brian is a lower percentage, so I think...
in the rules, he's allowed to respond. Okay, get your trigger hands ready. Oops, right. A planar diagram theory for the Daniel?
Well, can I say it in Dutch? That's a question. I don't know.
Correct. All right, Daniel, you get a second chance to articulate your view. You might want to try a little harder this time.
Yeah, so tensor networks are great if you don't care about sub-ADS locality. But if you try to do something like a matrix model that we think might be dual to flat space, like BFSS, then all the boundary sites are on top of each other and mixed together by gauge transformations. And I, at least, am not smart enough, so far at least, to come up with the tensor network for matrix quantum mechanics.
Fair enough. Any contestants want to respond and weigh in on the issue?
Well, I think B was still more accurate.
How come?
Because it is an accurate description of the universe at some energy scale, just not the one Daniel's thinking about.
Fair enough.
At what scale?
Electronic scale.
And if you care about the Eisen model, right? I don't know.
Yeah, some of us care about what actual systems do. When you pass current through them or stuff like that.
Just to make sure, can people in the back hear what's happening in the front? Yeah? Okay. Anyone in the audience want to weigh in on this topic? No? All right. Panel of evolving wisdom. What do you say? It's 2 votes to 1. Daniel gets the points. 10 points for Daniel. Von Neumann algebras. A, love them. B, they make my palms sweat.
Pretty polarized options.
The consensus view is B, they make my palms sweat. Let's see what our contestants had to say. Wait a minute. Ted is covering all his bases. I think he's disqualified in this round. Brian and John, you get 5 points each. Once again, actually, you know what? I'm going to give this one to Ted. Ted, you get to weigh in on this, this paper identification as well.
Okay.
Okay. Oops. Teleporting an unknown quantum state via dual classical and Einstein-Podolsky-Rosen channels. There are 6 authors. They get full points if they can name 2. Ted.
Charlie Bennett and Bill Wooders?
Correct. All right. 5 points for Ted. I'll just let you know, in the event that John Preskill had been competing, he would have had to give all 6 authors correctly.
Let's hear him, John.
Okay. So Ted, you want to articulate why both views are correct?
What?
Well, you put up both cards, right?
Yes.
So I guess you have to articulate why the correct answer is both A and B.
Isn't it obvious?
I guess it is.
No, I mean, I think it looks fantastically interesting that precise statements are being made about the change of algebra type and its connection to entropy. On the other hand, the mathematics involved is quite unfamiliar to most of us, and I'm planning to work hard to understand it.
Very good.
One might love a woman, but also she might make your palms sweat.
Noted.
That's a good metaphor, John.
All right. Next question. The universe is A type 1, B type 2, 3 type 3. What do we have here? 3 thumbs up. Points for Ted. Next question. I named the 3 first options. The 4th one is D, the whole operators on Hilbert space, acting on Hilbert space thing. Idea is suspect. Choices have been made at the front. Let's see what the audience has to say. The consensus view is type 1. What about our contestants? What do they think? All right. So Brian and John, they went with the conservative strategy. They get their 5 points. Once again, Ted and Daniel are going head to head. The paper is Black Holes and the Second Law. Ted?
I think we were tied exactly. I think we were tied exactly.
Well, then
I might have been slightly faster, but.
All right, Daniel. if you think you should take precedence.
Jacob Bekenstein.
That is correct. All right. It's once again time for you to articulate your contrarian view.
I forget, what was my, what were we talking about?
Operators.
Oh, operator, yeah. Okay, so, okay, good. Now I said this crazy thing to some people already, but now I'll say it to everyone. So in my understanding of quantum mechanics, the rules apply in the limit that the observer's brain is infinitely big. When the observer is part of the system, has finite size, finite entropy, they don't really have a right to infinitely precisely defined probabilities as predicted by the Born rule. And so if we're living inside a black hole or inside de Sitter space, there are fundamental limitations on how precisely we can do measurements, how big our memory, where we write down the results of the measurements, can be. So I don't think we have a right to a Hilbert space.
All right, thank you for that notably more carefully articulated view than some of your earlier responses. Any other contestants want to weigh in on that one?
Yeah. Suspect. I voted out, yeah. I voted suspect.
Anyone want to argue the type 1?
Universe is finite.
It's finite.
Well, but that's
Okay, John, you go for it.
Therefore, if the universe is infinite, it's still type 1. Beta type 1 just means everything. But
Not a finite temperature.
the real answer to this, yeah, sure.
I mean, the real answer to this question is that if by our universe you mean some sort of code subspace description of our effective physics, then the answer is type 1, because you're doing quantum field theory and curved spacetime. But if you mean something more subtle, like non-perturbative quantum gravity or things that deal with observer effects that Daniel talked about, then I don't think the question has a well-defined answer.
Fair enough. So I've been criticized in this one case for posing a slightly ambiguous question.
Oh, yeah.
Yes, okay. All right, panel of...
Wait, doesn't he have to get...
I said,
He gives a spiel.
I give my spiel.
It was a little long.
Now they're going to vote.
They have to vote on whether it's accepted.
Oh, were you tied? Yeah. All right. Did you feel that you should articulate it as well?
No, that's fine.
Panel of Evolving Wisdom. Once again, a split decision. It's a good thing we have an odd number of panelists. 2-1 in favor of Daniel.
Yeah.
The C, A, and F theorems of quantum field theory are A, deep consequences of the interplay between relativity and data processing, B, hopelessly poorly named, C, all of the above. Waiting. Our panelists are thinking carefully about this question. The consensus view is all of the above, definitely poorly named, but also, well, less popularly, deep consequences of the interplay between relativity and data processing. All right, what did our consensus have to say? Okay, Ted, you're up alone this time. You may have to articulate some unpopular thoughts. The paper is An Undulatory Theory of the Mechanics of Atoms and Molecules.
Do you need a hint?
Yes.
I'm going to guess. Louis de Broglie.
Oh! Erwin Schrödinger, I'm afraid.
He named his paper that?
I guess in German, though, probably.
In German, yes. Oops. Okay, so I guess we don't have to vote. Poor Ted doesn't get to. It's maybe for the best that Ted didn't get to explain why it wasn't a deep result.
I think it's for the best.
All right, question. Complexity equals A, action, B, almost anything, C, nothing of interest to physicists at least, or D, something else of interest to physicists. I suppose for this question to be unambiguous, well, let's leave it, keep it ambiguous. Oops. The consensus view, interesting. The consensus view is something else of interest to physicists. Contestants? All right. Everyone agrees. Well, 3 out of 4 agree it's interesting, and to physicists. Brian is going to have something else to say about it. Brian?
I'm not sure those are distinct options.
All right. Are you ready?
Sure.
Okay. The particle problem in general relativity. I think this is perhaps the hardest one on the list.
Yeah.
Oh! A gorilla.
Eye buzzer.
A gorilla press by John.
Einstein and Rosen.
That is correct. So what are we going to do with the situation? No points for Brian, but he gets to articulate his view because there was no one competing with him.
What was my view?
Well,
Almost anything.
almost anything.
Yeah, I think that includes D, so.
I can't.
Contained within the complexity class.
No, but something that's equal to almost anything is useless.
Yeah.
Depends on how big the almost is.
It has to be equal to something. Yeah, I think it has to be equal to something to be of interest.
It's equal to something. It's equal to almost anything.
Something particular.
Well, but Brian didn't say it was interesting. You just said it was almost anything, right?
Yeah, I thought it's interesting. It's just
Yeah.
anything.
The onus is not on Brian to convince us that it's interesting.
That's because he's interested in everything.
Does anyone want to argue that complexity can't be almost anything? Contra Brian. No? Rob? No?
You get 45 minutes.
Okay. Panel of Evolving Wisdom, what do you have to say? Oh, well, yes, it is Einstein and Rosen. He didn't get it, but because there was no one competing with him, we'll
get us a verdict.
he'll get a chance for the points. But in your wisdom, you could deny the points.
Yeah.
Oh, another split decision, 2-1 against Brian. Poor Brian.
Own colleague.
All right. Next question. In spacetimes containing black holes, computational complexity protects the validity of effective field theory. A, an attractive idea. B, a demonstrated fact. Or C, an obvious falsehood. Our contestants have made their choices. Let's see what the audience has to say. An attractive idea. All right. Contestants, what do you have to say?
I didn't vote.
Wait, are you deciding?
I was thinking.
Okay.
Ted recuses himself. And everyone agrees, 5 points each.
Except for Ted.
Anyone in the audience want to argue one of the contrary views? Since you're out there, we know you're there somewhere.
Could it be an unattractive idea?
Yeah. All right, Jonathan, here.
Contradicts the linearity of quantum mechanics.
I'm not trying to go so far as to say it's an obvious falsehood. I just feel it's unlikely. Just it feels like when you start to require a few different elements in order to protect physics, then that starts to feel a bit contrived. So like I'm happy with like throwing in one new element, but when you start to throw in too many, then I start to feel like a bit contrived. Yeah.
Did you want to add anything more, Aaron?
Contradicts the linearity of quantum mechanics.
Okay. Contradicts the linearity of quantum mechanics.
Don't you like
Should
to
that
live
worry us?
dangerously?
No. Not sure it's true, but. Anyone on the panel want to argue that it's not true, that it violates linearity of quantum mechanics?
Don't you like to live dangerously? I think there's an argument for B. The argument for B is if you have a gas of 10 to the 23 particles, and you add a Planck suppressed operator to the effective action, and then you wait for a second, then that operator changes the location of where all the particles are. So in that sense, it's obvious.
As plausible as many other conjectures in complexity theory.
Yeah.
Yeah. All right. Panel of received wisdom, what do you have to say? Oh, wait, no one. Oh, yeah, sorry, I lost track. Alex is contributing a thumbs up just to be encouraging. I appreciate that.
Aaron gets the
Aaron gets the thumbs up.
according to Alex.
Okay. I really did lose track of where we were here.
Next one.
Next question? Oops. Oh, no. Does there exist a non-perturbative bulk description of quantum gravity in anti-de Sitter space? A, yes. B, no. Clear options. Okay, our contestants have made their choices. The consensus answer is yes. We are optimists in this room and online. What do our contestants have to say? Agreed. Okay, very good. 5 points each. Once again, maybe I should give the audience a chance. Anyone want to argue against? Okay, excellent.
We don't know what it is, though.
One.
Yeah, I guess by exist I would mean a theory that exists, right?
Okay, there are no points to discuss on that round. Let's see what comes next. Oh, yeah. Well, should we do this anyways? We might as well. We're here. This is bonus 5 points. Who's going to be able to identify this paper? Quantum theory, the Church-Turing principle, and the universal quantum computer. Daniel.
Wait. Okay, Scott Aronson.
No! Minus 5 points for Daniel, so I didn't mention that we got it wrong.
That's a new rule. Wait a minute.
John Preskill.
David Doyle?
That is correct. 5 points for John Preskill.
Yeah.
All right. There's a well-defined and reliable holographic construction of de Sitter quantum gravity. My preferred approach is A, DSCFT, B, double-scaled SYK, C, de Sitter bubbles in ADS-CFT. Other is D, and E, you said well-defined and reliable. I'm still waiting. All right, our contestants have made their choices. What does the audience have to say? The overwhelming consensus is for you said well-defined and reliable. I'm still waiting. What about our contestants? Once again, consensus, 5 points each. And since we have the question here, I'm going to read the paper. Once again, 5 points are up for grabs. Toward it from bit.
Well, if you're going to penalize, we're not.
All right, Daniel.
John Wheeler?
That is correct. Yeah.
I thought you were trying to trick me.
You compensated your
I compensated
negative time.
for David Deutsch.
Next question. A wormhole was created in Google's lab in 2022. A, true. B, false. C, please define the term wormhole. Is everyone chosen? Okay. Consensus is for false. What did our panelists have to say? All right. Once again, consensus. I'll remind the contestants that they don't need to articulate what they believe. They can just try to go for the points. All right. Question. The universe outside our cosmological horizon exists and is independent of the visible universe. A, agree. B, black hole complementarity makes me unsure. C, what does the word exist mean?
You asked about created on the previous one.
All right, they've made their choices. Audience, what do you have to say? Slight consensus for what does the word exist mean? What about our panelists? All right, Brian gets the 5 points. Everyone else is in it for the 15. Let's see what the paper is. Holographic quantum error correcting codes, toy models for bulk boundary correspondence. These contestants have to get all authors correct and in the order listed on the paper. Let's go.
Okay. Fernando Pestowski, Benny Yoshida, Daniel Harlow, and John Preskill.
That is correct. All right, Daniel. You get your points. And now you get to articulate your contrarian view.
I agree. Well, because, okay, so we live in a bubble that's probably de Sitter. And there are other bubbles in the multiverse, which surely exists, which have zero cosmological constant and are exactly supersymmetric. And the people who live in those have an infinite amount of time and an infinite amount of space. So by my previous argument, they have a right to a well-defined quantum mechanical description of their experiences, which, and actually I think that we're living behind the horizon for them.
All right. Anyone want to disagree in the slightest with that rock-solid collection of assertions? Oh.
would you say that other branches of the wave function of the universe exist?
Well, I'm not sure if there is a wave function of the universe, but if there is, then the answer is yes.
Okay.
Anyone else? John, thank you.
I only want to articulate that I'm really shocked that Daniel keeps ending up in the heterodox position.
I'm always a contrarian.
Now, panelists, if you undermine Daniel, you reduce the chances that he's going to get the points. I'll just remind you. Anyone want to disagree with him? No?
I forgot the question.
All right, just a moment.
Yeah, existence. Yeah, define.
There we go. There's the question.
I would say it's not independent, even though it's there, because actually there's just one wave function of the whole universe in which everything is tied together.
Okay, very good. No one else weighing in? Oh, Alex.
Well, there was a talk by Raju last week where he said that in quantum gravity, in the if you have like a bounded region and the correlation functions inside the bounded region are completely extractable from the exterior, so it's well say that you just take the minimal bounded region of just one Planck volume, and then you know everything from it from the outside, and vice versa. So there's only one qubit, and that's it. So yeah, I don't think we even fully exist.
All right, it's time for our panel of evolving wisdom to make a decision. So, once again, a split decision, split a different way, but 2 points, 2 thumbs up for Daniel. He gets the points.
I agree with you, Alex.
Question, timescale to an error-corrected quantum computer with 1,000 logical qubits. A decade, B, decades, multiple. C, a century, D, not going to happen.
Sorry, those are logical or physical qubits?
These are 1,000 logical qubits.
Thanks.
Yeah.
Sorry, the slide says century, but the code says centuries.
Yeah. Yeah. If you want, you can put a century/centuries on there.
You can interpret it as centuries, I think.
Yeah. All right, let's see what the audience has to say. Decades, plural. Optimistic and conservative at the same time. All right. Let's see what our contestants say. All right. We have consensus.
Whoa.
So they can duke it out in the paper lightning round. If I have one. Yes. Black holes. Daniel.
Almiri, Maroff, Polchinski, and Sully.
That's correct. Your fast reflexes are serving you once again. Did you play College Bowl trivia?
In high school, yes. I was very fast.
Yes. John, what did you have to say? You were responding, yes. Yeah. That's the seniority penalty, I'm afraid. Okay. Well, before we continue, panel of evolving wisdom, how are our contestants doing?
Daniel is in the lead.
With how many points?
With 100 points.
And then?
You really want to know?
I do want to know.
Ted has 75, John has 70, and Brian has a little bit less.
All right. As it happens, this final question is worth 50 points. Anyone can win. They will each get a piece of chalk.
Oh, no.
And the question is, with all factors of Boltzmann constant, Planck's constant, and the speed of light included,
White chalk.
yeah, what is the Bekenstein-Hawking entropy of a black hole in 3+1 dimensions as a function of its area? The first person to get this correct on the board and then hit their buzzer gets the 50 points.
Supposed to write it where? On here or
On the board. Oh, behind us.
Ted! 50 points for Ted.
Correct? Is it correct?
It is. It is correct. Yeah.
Then why is the C cubed like in a double denominator?
Yeah, I think mine was right. No. Just leave my memory.
No, you're all
No,
wrong.
it
You
is.
didn't say to put G in.
Ted has G. Oh, yeah. All right. We'll just confirm with a panel of evolving wisdom.
50 points.
50 points.
Okay, congratulations.
Our winner is Ted Jacobson. He gets to deliver a seminar in California. And that's it, folks.
That's it from Qubit.
There's plenty of science left to be done. I'll see you all, I'm sure, plenty of times at conferences in the future. And look forward to all the wonderful science that we'll be doing together from here on out.
Thank you, Patrick.
Thank you.